Okay, now we're going to the Copernican revolution in the scientific revolution. This is, again, video 2 for AP Euro, April 1st. In 1543, Nicholas Copernicus, a Polish mathematician and astronomer, were concerning the revolutions of the celestial spheres. Copernicus was a cleric, and because he was afraid of the implications of the ideas contained in the work, he waited many years before he finally decided to publish. When he finally took the step, Copernicus cautiously dedicated the book to the Pope Paul III and included a preface that claimed that the ideas contained in it were just mathematical hypotheses. Even the language of the work was moderate, as Copernicus merely suggested that should the Earth revolve around the Sun, it would solve at least some of the problematic epicycles of the Ptolemaic system. However, since the Copernican or heliocentric system explains that the planets move in a circular motion around the Sun, it did not completely eliminate all epicycles. Despite his book's famous reputation, Copernicus's ideas did not stir a revolution in the way in which people view the planets and the stars. After Copernicus, the Earth-centered system would not go away that quickly. The Danish astronomer Tycho Brahe tried to come up with a different Earth-centered system rather than just relying on Ptolemaic system. Brahe had plenty of time on his hands to construct the best astronomical tables of the age, as his social life was non-existent after he lost part of his nose in a duel and rebuilt it with a prosthetic made of silver and gold alloy. Brahe proposed a system in which the moon and the sun revolved around the Earth, while the other planets revolved around the sun. Brahe's student, Johann Kepler, disagreed with his teachers concerning Copernicus's findings. Kepler ended up using Brahe's own data to search for ways to support Copernicus and eventually dropped Copernicus's planets move in a circular motion theory, instead proposing that their orbits were elliptical. However, it would take the great mind of the next age, Isaac Newton, to explain why this elliptical motion was in fact possible. Then you get Galileo. The first scientist to build on the work of Copernicus was a Florentine by the name of Galileo Galilei. In 1609, he heard about a Dutchman who had invented a spyglass that allowed distant objects to be seen as if they were up close. Galileo then designed his own telescope that magnified faraway objects 30 times the naked eye's capacity. Using this instrument, he noticed that the moon had a mountainous surface very much like the Earth. For Galileo, this provided evidence that it was a composed a material similar to that of Earth and not some pure substance, as Aristotle had argued. Galileo also realized that the stars were much farther away than the planets. He saw Jupiter had 4 moons of her own. This challenged the traditional notion of the unique relationship between Earth and her moon. Sunspots and rings around Saturn also put the whole Ptolemaic construct into doubt. Galileo also interested in the question of motion. He may not have really thrown a 10-pound weight and 1-pound weight from the top of the Leaning Tower of Pisa, but he did notice that heavier weights do not fall any faster than lighter ones. He also noticed that under ideal conditions, in a body of motion would tend to stay in motion. It was therefore relatively easy for him to deduce from this the possibility that Earth is in perpetual motion. Following the publication of the dialogues of the two chief systems of the world, the Catholic Church began to condemn Galileo's work. The Church authorities wanted Galileo not to publish any more writings on astronomy. Throwing caution to the wind, he wrote a book that compared the new science with the old. An ignorant clown, Simplicio, represented the old science. Pope Urban VIII thought that the book was making fun of him, and he put Galileo under house arrest for the remainder of his life. This did not stop Galileo from writing, although he was forced to send his manuscripts to Holland, where the mood was more tolerant. Sir Isaac Newton. The greatest figure of a scientific revolution was Isaac Newton. Newton wanted to solve the problem posed by the work of Copernicus, Kepler, and Galileo. How do you explain the orderly manner in which the planets revolve around the sun? Newton worked for almost 2 decades on the problem before he published his masterpiece, Principia, in 1687. Galileo's work on motion influenced Newton's sign of intellectual link between southern and northern scientists. Newton wondered what force kept the planets in elliptical orbit around the sun when theoretically they should be moving in a straight line. Supposedly, Newton saw an apple drop from a tree and deduced the same force that drew the apple to the ground may explain planetary motion. Newton finally posited that all planets and objects in the universe operated under the effects of gravity. It is important to remember that Newton was an extremely religious man and often wondered why, when he delivered public talks, his audience were more interested in his scientific discoveries than in theology. He spent a great deal of time making his silly calculations of biblical dates and practicing alchemy. More importantly, he began to experiment with optics, thus making the study of light a new scientific endeavor. It was Newton who showed the white light was a heterogeneous mixture of colors rather than a pure light. many believed it to be. Newton is also the father of differential calculus. Finally, Newton also eventually became the head of the British Royal Society, an organization committed to spreading the new spirit of experimentation. The impact of scientific revolution on philosophy. Among the philosophers affected, Among the philosophers affected by the new science was Francis Bacon, and Bacon led an extraordinary varied life. He was a lawyer and official in the government of James I, an historian and an essayist. The one thing he did not do in his life, it seems, was perform scientific experiments. What he did contribute to science was the experimental methodology in three major works: the advancement of learning, Novum Organum, and New Atlantis. Bacon attacked medieval scholasticism with his belief that the body of knowledge was basically complete and that the only task left to scholars was to elaborate on existing knowledge. Instead, Bacon argued that rather than rely on tradition, it was necessary to examine evidence from nature. Bacon's system became known as inductive reasoning or empiricism. In France, this debate over new learning became known as the conflict between the ancients and moderns, while in England it was known as the Battle of the Books. René Descartes. The French philosopher Descartes can in some ways be seen as anti-Bacon. For Descartes, deductive thought, also referred to as rationalism, using reason to go from a general principle to a scientific principle, provided for a better understanding of the universe than did relying on experimental method. However, like Bacon, Descartes believed that the ideas of the past were so suffocating that they must all be doubted. In his famous quote, "I think, therefore I am," Descartes stripped away his belief in everything except his own existence. Another way that Descartes broke with the past was by writing in French rather than Latin, which had been the language of intellectual discourse in the Middle Ages. Descartes was also a highly gifted mathematician who invented analytical mathematics. Descartes' system can be found in his discourse on method. In the work, he reduced nature to two distinct elements, mind and matter. The world of mind involved the soul and the spirit, and Descartes left the world to the theologians. The world of matter, however, was made up of an infinite number of particles. He viewed this world as operating in a mechanistic manner, as if a constant whirlpool that provided constant contact among the various particles. Blaise Pascal. Pascal saw his life as a balancing act. He wanted to balance what he saw as the dogmatic thinking of the Jesuits with those who were complete religious skeptics. His life's attempt to achieve this balance is found in the Pensées, particularly in the idea that became known as Pascal's wager, in which Pascal concluded that it was better to wager on the existence of God than on the averse, because the expected value that comes from believing is always greater than the expected value of not believing. Pascal became involved with the Jansenists, a Catholic faction that saw truth in St. Augustine's idea of total sinfulness of mankind, and the need for salvation can be achieved through faith because we are predestined, ideas that were followed by the Calvinists. Okay, so now we're transitioning kind of out of science and getting more into like Enlightenment thinkers at this point, because next you get Thomas Hobbes and John Locke. So I'll briefly do Hobbes and we'll save the rest for later. Thomas Hobbes personally knew Galileo, Bacon, and Descartes, and was also friends with William Harvey, who, rather than relying on writings of ancient Greeks, used dissections to show the role the heart plays in circulation of blood through the body. His contact with the leading figures in the world of science influenced Hobbes to apply the experimental methods they used in the study of nature to the study of politics. Hobbes was horrified by the turmoil of the English Revolution and was convinced of the depravity of human nature. Humans were like animals in that they were stimulated by appetites rather than noble ideas. Hobbes wrote in his classic work, Leviathan, that life without government was nasty, brutish, and short. Hobbes' view of the depravity of human nature led him to propose the necessity for absolutism. Man formed states, or what Hobbes called the great Leviathan, because they were necessary constructs that worked to restrain human urges to destroy one another. Out of necessity, the sovereign had complete and total power over his subjects. The subjects were obliged never to rebel, and sovereign must put down rebellion by any means possible. When the parliamentary side won the Civil War, Hobbes went back to England and quietly went on with his life. He rarely accepted any established power and could therefore live under Cromwell's firm rule. His theories did not please traditional English royalists because his brand of absolutism was not based on the divine right theory of kingship. So we'll stop there and pick up tomorrow with John Locke. Let's go look at key concepts real quick. I think there's some that are in Unit 3. Or is it all Mercantilism? It's all Mercantilism. It's like Mercantilism stuff, balance of power, absolute. Absolutism. Yeah, I think that's it. Okay, so it's going to Unit 4, Scientific, Philosophical, and Political Developments. So we'll look at 4.2, Scientific Revolution. New ideas and methods in astronomy led to individuals, including Copernicus, Galileo, and Newton, to question the authority of ancients and traditional knowledge and to develop a heliocentric view of the cosmos. Anatomical and medical discoveries by physicians, including William Harvey, presented the body as an integrated system, challenging traditional humoral theory of the body and disease espoused by Galen. Francis Bacon and René Descartes defined inductive-deductive reasoning and promoted experimentation and the use of mathematics, which would ultimately shape the scientific method. Alchemy and astrology continued to appeal to elites and some natural philosophers, in part because they shared with the new science the notion of predictable and knowledgeable universe. At the same time, many people continued to believe that the cosmos was governed by spiritual forces. All right, then it gets into the Enlightenment. We're not really there yet. It has 4.4, 18th century society and demographics, which we covered a little bit of that. In the 17th century, small landholdings, low productivity, agricultural practices, poor transportation, adverse weather limited and disrupted by the food supply, causing periodic famines. By the 18th century, the balance between population and food supply stabilized, resulting in steady population growth. Which are not really the 1700s yet. I think a lot of this is going to come later in the review. If not, I'll read it at the end, but that's it for now. Just see if you can find any key concepts that deal with life and society that might be in Unit 3, Unit 4 from the key concepts. But anyway, we're going to stop there. Y'all